Hi everyone. I'm going to try and explain the solution to this question 9 from the review worksheet. So the question stated, and let me see if I can just quickly grab the question here. The question 9 said, express the vector 5, 3 as a linear combination of a hat and b hat. So remember the hat means unit vector for A and unit vector for B. Now vector A is this one and vector B is this one. So that's our starting information. Now let's see how we go. Whoops, where did I end up then? I wanted that page. So we first have to find unit vector A hat. So we do this in the usual way. It's vector A divided by the modulus, or the length of vector A. So there's vector A, 3i take 2j, and the length of that vector is root 3 squared plus 2 squared, or root 13. Now, it's much easier to work in fractions rather than any sort of decimals with rounding off that introduces errors. So 3i divided by root 13 is this number times I hat, and minus 2 divided by root 13 times j hat. That vector there is in the same direction as vector A, but a length of 1. Now I'll see if I can demonstrate what I mean by that here. Let's just turn off vector B. There's vector A pointing down from the origin to the coordinate 3, 2. Now if I were to have a unit vector A hat, it would have to point in exactly the same direction but stop somewhere here once it had reached a length of 1. Now there it is. There's vector A hat, and that would be the one we just calculated out. So it would be 3 over root 13 times I minus 2 over root 13 times j. In the same way, we calculate vector B hat. There's vector B. The length is root 2 squared plus 1 squared, or root 5. So there would be where vector B hat belongs. Now let's see if I can show you that on my picture. So let's put vector B there. There's the original vector B, and I want a B hat, which is the length, same direction but length of 1, and there it is. So I'll turn off A and B now. Now the question is, we want a linear combination of these two that ends up pointing up to there, up to the coordinate 5, 3. So it'll be some multiple of A hat plus some multiple of B hat. Now that's where all the fun starts in our working. I've lost my answers. There we go. So let's go. There it is. I don't know what multiple I need, but P times A hat plus some different number Q times, that's what we mean by a linear combination. Just scalar multiples of the unit vector A hat and B hat, equaling this desired 1, 5, 3. So I write this in basis vector 5i plus 3j. Now P would multiply, there's A hat from above, and B hat is this one from above. Then we expand through, multiply by P, so 3P over root 13 minus 2Q over, why did I say Q? Oh yes, I know, because that P would multiply by this, but it would be times basis vector J, so it ended up over here. And then Q times 2 over root 5 times I, so that is an I component, which ended up here. I've grouped together. So P times this I component, Q times this I component, group them together times I hat. Then P times this J component ended up there, and Q times this J component ended up there. So I now have that this bunch of information here with unknown P and Q equal 5. There it is, 5 equals that times that. And this bunch of information with P and Q, same numbers, equals 3. So there it is there. These are two simultaneous equations in two unknowns. I decided to use the elimination method. I decided that if I multiplied the second equation here by negative 2, then this part would be equal but opposite to this term, and the Q part would disappear. So equation 1, 5, minus 2 times 3, then it'll be this bit, 3 over root 13, minus 2 times this bit, so minus 2 times that bit. And then these ones, as I said, they're equal and opposite, they go away. So that is -1. Now, by the time I take away 4, sorry, that's add, take negative by negative is add, I end up with 7. And then I calculate P equals this. I substitute back, and I get the answer for Q. And here is my linear combination. That's the number P, that's the number Q. Now, let's just see whether or not that worked. So I've written an equation down here with that number times A hat and that different number times B hat. And there it is. It multiplies each vector and adds them, and it gives the desired answer. Okay, that's a good, fun question. Lots of techniques. Thanks for watching.